Good morning. Today we'll talk about angles, different angles in a circle. We know so far inscribed angles. We know so far also central angles, but today we'll be introduced to two more angles that are called interior angles and exterior angles. The first part of your lesson, a tangent is a line that intersects the circle in one point. So if you have a circle like that, if a line intersects that circle in one point, this is called a tangent line. Also, if you have a tangent and a radius, and when they meet at the point of tangency. So the line, which is the tangent, and the radius meet at one point, then this angle must be a 90-degree angle. All of this at this point is like all the information that you have known before. Another term that we learned about, it's a secant. So if you have a circle and a line intersects in a circle in 2 points is called a secant. So a line that intersects in a circle into 2 points, then we call it a secant. An inscribed angle, there's a difference between the inscribed angle and a central angle. With the inscribed angle, the vertex would be anywhere on the circle itself. And with the inscribed angle, it's equal half of the intercepted arc. So I recommend as soon as you look at an angle, try to figure out where's your vertex of that angle. Whether it's on the circle, then it would be an inscribed angle. And with an inscribed angle, it's equal half of the intercepted arc. But the central angle, if you have a circle, the central angle would be the vertex would be on the center of the circle. And with this central angle, it's equal to the intercepted arc. So the central angle is equal to the intercepted arc, but an inscribed angle is equal half of the intercepted arc. We have 3 questions coming up. You want to find X and Y for the first one. X and Y, both of them are representing angles. Let's look at the vertex of that angle. The vertex of this angle is eventually on your circle itself. So since it's on the circle itself, then each one of them are inscribed angles. So X and Y, both of them are inscribed angles. And if it's an inscribed angle, you will know it equal half of the intercepted arc. So the best way to figure out where's the intercepted arc is try to extend those 2 lines that makes that angle. Now it would be clear that where is your intercepted arc. So the intercepted arc is 120. The same thing for Y. If I extended the 2 lines that make that angle, then the intercepted arc is equal to 120 as well. Since they're both sharing the intercepted arc, then the measure of angle X is equal to the measure of angle Y, which is equal half of the 120, which is equal to 60. So each one of the measure of X and Y is equal to 60 degrees. Now, the following question, AB is a diameter of that circle. So this is AB is a diameter, which will make the measure of this arc, since it's a diameter, it's cut the circle in half. So this is 180. Now, it's 180, which means it's also a semicircle because it's half of your circle. You want to find the measure of angle C. The measure of angle C, if I extended the 2 rays, the intercepted arc will be eventually this arc, which is the 180. Angle C is corresponding to that arc. And think about also angle C is an inscribed angle because the vertex is on the circle itself. So angle C will equal half of the 180, which will result in this angle will equal to 90 degrees. So the measure of angle C is equal to 90 degrees. Last question. You want to find the measure of angle C in this circle. Again, looking at the measure of the angle C is considered a central angle because the vertex of this angle is on the circle on the center of the circle. So the central angle is equal exactly the intercepted arc. So if I extended those two rays, that makes that angle. The intercepted arc is 120, so it's equal 120. Remember, the central angle is equal exactly the intercepted arc. The third type of angle would be an interior angle. And with an interior angle, it's somewhere inside the circle, but it's not in the center of the circle. So you will see that the interior angle is not an inscribed angle, not an central angle, but it's an interior angle, which is somewhere in the circle, which means that the vertex will be inside the circle itself. I think about an interior angle, I look at it as a bow tie. So I make a bow tie out of my angle. And when I see my angle is inside that bow tie, I know it would be half of the sum of the two intercepted arcs. So half of 95 plus 31. So again, think about it like the interior angle looks like a bow tie. And with a bow tie, you will have half of the sum of the two intercepted arcs. So 95 plus 31 all divided by 2. So this angle is equal to 63. So measure of angle 1 is equal to 63. So this is the third type of angle that's related to a circle. So we discussed central angles. We discussed inscribed angles. The third type is an inscribed angle. The last one that we're going to go over is called an exterior angle. From its name, the vertex will be outside the circle. And if you have to extend the two rays that makes this angle, or the two sides that makes this angle, you will see two different arcs, 1 and 2. So with an exterior angle, it's still equal half of the big minus the small. So half of the big arc is 96 minus the small arc, which is 24. So 96 minus the 24, that's equal 72. Divided that by 2, it's 36. So measure of angle 2 is equal to 36. So that concludes all of the type of angles that it would be related to a circle. You have central angles where the vertex is on the circle. I'm sorry, the central angle where the vertex will be inside the circle on the center of your circle. Interior angle would be somewhere inside the circle. Exterior angle will be outside the circle. And finally, inscribed angle would be on the circle itself. You can definitely skip that part. Let's go through a summary again about the different type of angles that's related to a circle. The first one, we learned about the central angle, and the central angle would be on the center of the circle. With the central angle, it's equal exactly the measure of arc A. With the inscribed angle, the vertex will be on the circle itself, and it will equal half of measure of arc A. The interior angle, I think about as a bow tie. And with the interior angle, it's equal half of the sum of the two intercepted arcs, which makes the bow tie. So B plus A. The last one is an exterior angle. So it would be half of the difference between the A minus the B. And that concludes all of the different type of angle that it's related to a circle. The following question, you have a circle and there's many different chords and tangents and secants and angles and different type of angles. But think about it as a puzzle, that if you found one piece of that puzzle, then you can move on to the second piece and you keep on going to find the different pieces of the puzzle till you finish all of the questions from 0 to 9. The first one is asking you for the measure of arc DN. So you want to find the measure of this arc, which is right there. This arc, if I think about it carefully, it's not related to any central angle. It's not related even to an inscribed angle, but I see it's somehow related to an interior angle. So I'm making my bow tie. And with my bow tie, this is 42, so this must be 42 as well. So I can set an equation, and I'll say that 42, which is my interior angle, is equal half of the sum of those two intercepted arcs. The measure of arc DN, I'll just name it X for now. So X plus the 64. From there, I can just solve for X. So I'll multiply by 2 on both sides to get rid of this half. So it's 84 equal to X plus 64. Subtracting 64 on both sides. And that's equal to 20. So the first one, we succeed to find the first piece, which is arc DN is equal to 20. I'm going to go back again, and I'll try to put it right away on my circle. So this is 20. Let's move on to 1, which is you want to find arc AD. So here's arc AD. And with this arc, you have a diameter. So if you have a diameter, this whole big thing from this point, from B, arc, the measure of arc B, D, all the way to K, it's equal to 180. I have this is 64, this piece is 64, this piece is 20, this piece is 28. So the remaining piece would be 180 minus the sum of all of those pieces, which is 20, 28, and 64. So I'll put here arc AD is equal to 180 minus 64 minus 20 minus 28, which is equal to 68. So the measure of arc AD is equal to 68. So I succeeded to find this part. I told you it's like a puzzle, and you're just trying to find one piece to get to the other piece, to get to the other piece, and you keep on going the same way. Now, let's move on to number 2, which is finding the measure of angle NYB. So N is right there, Y is here, and B is here. So it's this measure of this angle that's outside the circle. Now, thinking about measure of angle NYB, we need to figure out whether it's a central angle, whether it's an inscribed, whether it's a central angle, inscribed, exterior or interior. Eventually, this is outside the circle, so it's eventually the exterior angle. So you can figure out that this rule for the exterior angle would be the half of the difference of the two intercepted arcs. So if I have to extend this one so I can see better the two arcs, the two arcs that are corresponding to that exterior angle that's outside is 64 and 28. So the measure of angle NYB is equal to half of the big arc, which is 64, minus the small arc, which is 28. So 64 minus the 28, divided that by 2, that's equal to 18. So the measure of this exterior angle is equal to 18, and I'll put the information right here on in my small table. Moving on to 3, you want to find the measure of DYN. So DYN. So again, it's another exterior angle. And with that exterior angle, you have two arcs again. If I extended those two rays, that makes this angle. I can see clearly my two arcs. So the two arcs that are connected with that exterior angle, which is DYN, is 68 and 20. So the measure of angle DYN is equal to half of the big arc is 68 minus the small arc, which is 20. It's very critical that you know the differences between the 4 different type of angles that are related to a circle, so you can figure out the difference between all of them, and because each one of them has a different rule. So 68 minus 20 divided by 2, 24. So the measure of this angle is 24. Moving on to the measure of arc KS, which is right there. This arc is related to that inscribed angle. So if I extend the rays, I'll definitely see it better. So the 55, which is an inscribed angle because the vertex is on the circle, is related to that arc. So if this is 55, 55 times 2 is equal to 110. So that arc must be 110. Recall the inscribed angle is equal half of the intercepted arc. So arc KS is equal to 110. Now I'm left over with BS. So this arc, remember, this is half of a circle. Because it's a diameter, this is the diameter, so it's half of a circle. So I can find BS by saying that this arc will be 180 minus the 110, which is equal to 70. So arc BS is equal to 70. Moving on, I need to find angle H. So this angle that's right here. And angle H, it's outside the circle, so it's considered an exterior angle. If I extended my 2R rays, that makes that angle. Here is my big one, big arc, and here is the small arc. So to find angle H, I'll say it's half of the big minus the small. The small one is I can see it right away. But the big one, it's 360. The remaining of the circle is your big arc. So 360 minus the 110 is equal to 250. And also you can add all of these arcs together and you will find it again, it's 250. But think a simple way to think about it, that if this arc is 110, then the remaining big arc, the remaining major arc will be 360 minus 110, which is the 250 that I get from here. Now I'll do 250 minus 110, divide that by 2. So the measure of angle H is equal to 70 degrees. Now I can move on and find number 7, which is angle BSH. So BSH, I'm trying to find a different color. BSH, the vertex is on the circle itself. This is the first question that you have to ask yourself. Where is the vertex of that angle? So since the vertex is on the circle itself, then you can say right away it's an inscribed angle. The inscribed angle is equal half of the intercepted arc. And if I look at the intercepted arc, it's all of that together. Do you see that? So it's all of that angle, all of that arc together. BS is equal to, did we figure out the value of BS? So BS, the arc BS was 70. So the remaining one, 360 minus the 70, and that's equal to 290. So now I can figure out the measure of angle BSH, which is equal half of the intercepted arc, which is 290. 290 divided by 2, that's equal to 145. So the measure of this angle is equal to 145. Hang in there, we're almost done. You want to find the measure of angle BKH. So let's figure out what type of angle is that. So angle BKH is right there. And the measure, and this angle again is considered, since the vertex is on the circle, then it's considered an inscribed angle, and an inscribed angle is equal half of the intercepted arc. You have this whole arc is equal to 180. So 180 divided by 2 is equal to 90. So the measure of angle BKH is equal to 90. Finally, I have one more angle to go, which is DKH. DKH. So let me draw this angle. So DKH. Again, this is considered an inscribed angle because the vertex is on the circle. You have the intercepted arc is right all of the way here. And this whole arc is equal to 180 plus 20 plus the 28, which is equal to 228. So I figured out that this whole arc is equal to 228. If you're looking at 228, divide that by 2. That's equal to 114 because it's an inscribed angle. You take that arc and divide it by 2 because it's simply an inscribed angle. Moving on to question number 10. Measure of arc NO is equal to 30 degrees. Also, measure of arc RS is equal to 70 degrees. So this is the information that's given to us in this problem, and you want to figure out the measure of arc R and S. So R and S, so it's this angle that's right here. This angle is considered an inscribed angle because the vertex is on the circle. With this inscribed angle, if this arc is 70, which is the one that's linked to this angle, so 70 divided by 2 is 35. Moving on, ROS. So it's this angle that's right here. And this angle here, again, it's an inscribed angle that's have the same arc here, which is 70. So again, 70 divided by 2, it's equal to 35. RPS. So now let's move on to the other angle here. Let's figure out that this is not a central angle because the vertex of this circle is not on the center of the circle. So it's considered an interior angle. With an interior angle, I can do my bow tie. So here's my bow tie. And the two arcs that are linked to that bow tie is 70 and 30. So I'll do half of, it's the sum of both of them. So half of 70 plus 30. 70 plus 30 is equal to 100 divided by 2. It's equal to 50. Finally, the measure of angle M, which is right there. This is considered an inscribed angle. I'm sorry, an exterior angle. It's not an inscribed angle because it's the vertex is outside the circle. So it's considered an exterior angle. And if I extended my rays, I can see clearly my two arcs that are like linked to that exterior angle. So it would be the half of the difference between them, which is 70 minus 30. 70 minus 30 is equal to 40 divided by 2. It's 20. We'll have to admit that this question is definitely easier than the one that we have completed for number 9. Last question. Find the measure of arc JL, which is this arc. If the measure of arc KTM, so KTM, so it's all the way here, that's equal to 195. And the measure of angle P is equal to 72. So this angle here, that's equal to 72. Now, looking at angle P, eventually this is an exterior angle. And if I extended my rays, I can see eventually the two arcs that are like linked to that angle. The first arc is the MTK, and the second arc would be IJ. So if I want to write an equation for that, I will say that the measure of an exterior angle equal half of the big minus the small, which is the big arc minus the small arc. And the measure of the exterior angle, let's replace this one. So the exterior angle would be replaced by 72. The big arc would be replaced by 195. And the small arc is not given to us, so this is the arc that we want to really find, so I'll replace it by an X. So now I'll work backwards to find the measure of arc IJ or X. We named it X to make it simple, like we can simplify it better. So I'll multiply by 2 on both sides. So 72 times the 2 is equal to 144 equal 195 minus the X. I'll add X on both sides. So it would be X plus the 144 equal to 195. I'll subtract 144 from both sides. So X is equal 195 minus the 144, which is equal to 51. So the measure of arc JL is equal to 51. That concludes today's lesson. And I'm hoping that you enjoyed today's lesson. It was quite lengthy compared to different lessons that we've completed, but this is a long lesson, I have to admit that. Have a great day and proceed after you're done with your notes, proceed to your assignment. Bye.